Learning Outcome 9.4. Find regions of convergence for time domain functions using tables and integrals. We're going to look at an example. X of t is 3e to the minus 4tu of t minus 2e to the minus tu of t. We want to determine the Laplace transform for this function and the corresponding region of convergence. Let's break this into two parts, an x1 and an x2. For the x1, it's going to have a transform, x1 of s, which is 3 over s plus 4, and the region of convergence for that is where the real part of s is greater than negative 4. This comes from property 6 in table 9.2, and it's very similar to the example that's worked out in Learning Outcome 9.192. Note that there is a dual-headed arrow here because these are not equal. This is a function of time, which is not equal to the transform, even though they are things that represent the same signal. The second part of our time function, x2, is minus 2e to the minus tu of t. This has a Laplace transform, x2 of s, is negative 2 over s plus 1, with a region of convergence where the real part of s is greater than negative 1. So by linearity, if we add our two signals in time, our transform will be the sum of the two transforms. Now you also need to consider what the region of convergence will be. And it must hold that both of these are true, because the analysis integral has to converge for both parts of this. Therefore, we need to combine these two regions of convergence. We need to have that the real part of s is greater than negative 4 and that the real part of s is greater than negative 1. When we consider this, that means that the real part of s has to be greater than negative 1. That's where both are true. We can look at this graphically. This is the region of convergence for the real part of s greater than negative 4. This is the region of convergence for the real part of s greater than negative 1. They both are satisfied where they overlap, and that's going to be when the real part of s is greater than negative 1. Let's try another example. X of t is 3e to the minus 4tu of t minus 2e to the minus tu of negative t. Notice here we've got this negative inside of our u. That's going to flip it around where we're talking about time less than 0. We want to know what's the Laplace transform and the corresponding region of convergence for this new function. Looking at our table 9.2, the first part does not change from the previous example. We'll still have a Laplace transform of 3 over s plus 4 with a region of convergence where the real part of s is greater than negative 4. The second part now is a little bit different. Now we need to look at transform pair 7 from table 9.2. This is going to have a Laplace transform of 2 over s plus 1. That negative gets used up in part of the transform. Make sure you look at property 7 in table 9.2. But now our region of convergence is the real part of s less than negative 1. Again, by linearity, our total Laplace transform is going to be the sum of these two parts. And again, the region of convergence must satisfy both these ROC conditions. So we need to have the real part of s greater than negative 4 and less than negative 1. This means that our real part of s has to be between negative 4 and 1. Now let's look at this graphically. Real part of s greater than negative 4 is the region to the right of the negative 4 on the real axis, that half plane. Real part of s less than negative 1 is the half plane less than negative 1. Those two intersect between the negative 4 and the negative 1. Note that all regions of convergence are bounded by a vertical line. So they'll either be half planes or they will be a vertical strip within your plane. The lines will always be vertical, never diagonal, never horizontal, never curved. The boundaries will always be vertical lines, And we can either have a region of convergence to the left, between, or to the right of one of those lines.